We've got three forces and they're shown in the diagram with their magnitudes and their directions. We're told that they are in equilibrium, which means the whole system is balanced. And I'm asked to show that theta is 41.4. Well, so I don't know what P is, and I want to avoid that for the time being. That's in part two. What we can do is resolve the forces horizontally, because if you do that, then P has no impact whatsoever. It has no horizontal component. So I'm going to look at the forces to the right, first of all, and that is going to be 6 sine theta. The reason for this is I can draw a little triangle with an upwards component and a sideways component, and this part is opposite the angle. That's what makes it the sine component, or you could write down sine theta is this thing divided by 6, rearrange it, so this thing is 6 sine theta. Another way to think about it is just to remember if you turn it in, turn the vector in to the angle, then it's this bit is always the cos part, or the adjacent part. So just find a way of being able to work out the components reasonably quickly. For the 4 newtons, it's going to be a very similar sort of thing. It's going to be 4, and then it's going to be sine 2 theta. Again, I'm rotating it into the angle would be the cos part. That's the part pointing up. So the other one is going to be sine. It's going to be this thing here. I've got a trig equation to solve. I can divide through by 2 to start with, and then expand sine 2 theta as 2 sine theta cos theta. This is one that's just worth knowing. As soon as you see either sine 2 theta, you can write that down, or if you see this, you can write it back as sine 2 theta. So learning it has a lot of advantages. If you haven't learned it, you're having trouble, then you're going to have to go back to your addition formulae given in the formula book. And in any case, make sure you can do this to derive it. So let B equal A, then we're going to get sine A plus A, which is 2A, equals sine A cos A plus sine A cos A. That's where the 2 sine A cos A comes from. So it's a really nice result there. That means that 3 sine theta is going to equal 4 sine theta cos theta. Now, in this case, I can just divide through by sine theta because I know that theta is not 0. I suppose I technically don't know that. It could be in theory. Um, or 90. So I know 90 would make it equal to 1. So that's when sine theta is 0. So I can just cancel it out basically. But yeah, another solution would actually be theta is 0, but they sort of seem to be skipping that one. So that means that cos theta is going to equal 3 over 4. I can just do inverse cos. (41.409). Which rounds to 41.4 degrees. Hence, find the value of P. So now we can do the same again, but resolve up. This is part 2. We'll resolve in the vertical direction. So I can just say that the downwards one, P, is then going to equal 4 cos 2 theta, which is now 2 times this 41.409, plus 6 cos theta, or 41.409. Just use the answer button. Plus we get a nice answer of 5. You could, in theory, do this without a calculator, I think, find the exact value of sine, but there's, yeah, there's no need, is there? We just want to quickly find it. In the next part, we're completely changing the setup. So the force of magnitude 4 newtons is removed, and the force of 6 newtons is replaced by a force of 3 newtons acting in the same direction. Let's get a diagram down showing what's going on. So we've got this particle, and this time, we've got a vertical going up. This force is now 3. Note it's still acting in the direction 41.409. And the other force, P, that we found, so this part is relying on us having found P correctly. If you haven't, you're just going to have to make a value up and maybe get some method marks. That's going to be 5. Okay, this is our new setup. And then we're asked to find the magnitude of the resultant of these two remaining forces. So I'm going to do a very sort of similar thing. I'm going to resolve to the right, and that's simply going to be 3. Well, I'm finding, finding the force to the right. I'm going to get 3 times sine 41.409. And let me work out what that is. 1.9842. And then looking at it, I can see that the downwards force is going to be greater. I've got 5 going down. 3 cos is definitely going to be less than that because cos is always less than or equal to 1. So I'm going to get 5 minus 3 cos 41.409. 2 points, probably 2.75 to be fair, because I've rounded it. So I'm going to write it as 2.75. Right, and now to find the magnitude. So I've got these two forces, and ultimately I'm going to have this 1.9842 acting to the right, and then 2.75 acting down. This is going to be my overall force. So I want to find the magnitude. Just need to apply Pythagoras' theorem because this is a right angle. I'll go straight to it. Okay, 3.391. Or 3.39 newtons. So that is the magnitude. Okay. And then the direction of this resultant. So I'm going to work out this angle here. You could actually work out more. It makes sense to find the angle actually that it's kind of originating from rather than other ones. So I need to find theta. Okay, and I'll do tan, inverse tan of that. Could have done it all in one go. 54.188. So the direction is 54.2 degrees below the horizontal.